Good morning, good afternoon, and good evening. Thank you for joining Go Day on Google Open Source Live. If you haven't attended Open Source Live before, it's a monthly web series where each month we explore a different topic within open source. Today, of course, is all about Go. My name's Matt. I'm a product marketing manager at Google, where I lead the Go team's marketing efforts and enterprise engagement.
Thanks, Matt. Hey everyone, I'm Alice Merrick. I'm a user experience researcher here at Google, where I conduct research for the Go team, including the annual Go Developer Survey. I can't wait to co-host today's amazing event covering all things related to Go. Matt, can you please tell folks what's in store for them today?
Yeah, we have some really interesting topics today. If you're looking to learn more about Go, you're in the right place. We'll kick it off with a really exciting talk from Ian Lance Taylor, who will walk us through using generics in Go. But before that, we have a couple housekeeping items.
Don't forget to put your questions in the live Q&A forum below the live stream window. Speakers are ready to answer your questions live. And if you're viewing in full screen, you'll need to exit full screen first to see the live Q&A forum. Our sessions have been pre-recorded to allow for accurate transcripts and so that speakers can focus on answering your questions. Once we're done, don't forget to join us at the after party on Google Meet. You'll see a button to join in the event page at the end of the last session. Oh, and last but not least, use the hashtag GoogleOSLive to share your experiences on social media.
And with that, Ian will take it away.
Hi, welcome to Google Open Source Live. My name is Ian Lance Taylor. This talk is pre-recorded, so I'm speaking to you from the past. My present self will be watching the chat down there, so feel free to ask questions. We'll be talking about when to use generics, which is a new language feature that won't be available until the future. Generics will be available in the Go 1.18 release in February 2022. To start with, what are generics? Generics let you write data structures and functions with types that are specified later. In current Go, functions have parameters, of course. With generics, functions can have a new kind of parameters called type parameters. And types, which currently can't have any kind of parameters, can also have type parameters. Functions and types with type parameters can then be instantiated with type arguments. For type parameters, we say instantiated rather than called, because the operation occurs entirely at compile time, not at runtime. Type parameters have constraints that restrict the set of permitted type arguments, much as ordinary parameters have a type that restricts the set of permitted ordinary arguments. For example, consider this function that takes a map and returns a slice containing all the keys in the map. In current Go, it's easy to write this function for any specific map type. This example works for maps of type map string int. But you need to write a different copy of the function for each map type that you want to use. Or you could write this function using the reflect package, but that is awkward to write and relatively slow to run. Using the reflect package here is complicated enough that I won't show an example. Or you could use type parameters. With type parameters, you can write this function once in a way that will work for all map types and will be fully type checked by the compiler. Here the type parameters are named k and v. The ordinary parameter m, which used to have type map string int, now has type map kv. The type parameter k is the key type of the map, so it has to be comparable. This is expressed by saying that the constraint for k, which again you can think of as the meta type for the type parameter, is the pre-declared constraint comparable. The type parameter v can be any type, so its constraint is the pre-declared constraint any, which permits any type. The body of the function is just like before, except the variable s is now type slice of k rather than type slice of string. There are a lot more details of these new language features that I'm not going to discuss here. The important point is that functions can have type parameters, and although this example doesn't show it, so can types. The link on the screen shows you where you can read a lot more about this. What I'm going to talk about today is not what generics are or how to use them, but rather when to use generics and when not to use them. To be clear, this talk will provide general guidelines, not hard and fast rules. Use your own judgment, but if you aren't sure, use the guidelines I'm going to discuss now. Let's start with a general guideline for programming in Go. Write Go programs by writing code, not by defining types. When it comes to generics, If you start writing your program by defining your type parameter constraints, you're probably on the wrong path. Start by writing functions. It's easy to add type parameters later when it's clear that they will be useful. That said, let's look at those cases where they can be useful. One case where type parameters can be useful when writing functions that operate on the special types that are defined by the language: slices, maps, and channels. If a function has parameters with those types, and the function code doesn't make any particular assumptions about the element types, then it may be useful to use a type parameter. For example, the map keys function that we saw earlier. That function returned a slice of all the keys in a map. The code didn't assume anything about the map key type. That made it a good candidate for using type parameters. As I mentioned before, the alternative to using type parameters for this kind of function is typically to use reflection. But that's a more awkward programming model, it's not statically type-checked, and it's often slower as well. Another similar case where type parameters can be useful is for general-purpose data structures. By general-purpose data structures, I mean a data structure like a slice or a map, but one that's not built into the language. For example, a linked list or a binary tree. Today, programs that need such data structures write them with a specific element type, or they use an interface type. Replacing a specific element type with a type parameter can produce a more general data structure that can be used in other parts of the program. Replacing an interface type with a type parameter can often permit the data to be stored more efficiently as well. In some cases, using a type parameter instead of an interface type can mean that the code can avoid type assertions and can instead be fully type-checked at compile time. For example, here's what a binary tree data structure might look like using type parameters. This is an example of a type that has a type parameter. Each leaf node in the tree contains a value of the type parameter t. When the tree is instantiated with a particular type argument, values of that type argument will be stored directly in the leaf nodes. They will not be stored as interface types. And this shows a method on the generic binary tree. Don't worry about the details here or the formatting used to fit the code onto the slide. The point is that this is a reasonable use of type parameters because the tree data structure, and even the code in this method, is largely independent of the element type t. The data structure does need to know how to compare values of element type t, and it uses a passed-in comparison function to do that. You can see that on the fourth line in the code here, in the call to bt.comp. Other than that, the type parameter doesn't matter at all. This binary tree example illustrates another general guideline. When you need something like a comparison function, prefer using a function rather than a method. We could have defined the tree type such that the element type is required to have a compare or perhaps a less method. This would be done by writing a constraint that requires a compare or less method, and it would mean that any type argument used to instantiate the tree type would need to have that method. But that would mean that anybody who wants to use tree with a simple data type, like int, would have to define their own int type with a compare method. And anybody who wants to use tree with a custom data type would also have to define a compare method for their data type, even if it's not otherwise needed. If we define tree to take a function, as we did in the example code that we just saw, then it's easy to pass in the desired comparison function. And if the element happens to already have a compare method, we can simply pass a method expression like elementtype.compare as the comparison function. To put it another way, it's much simpler to turn a method into a function than it is to add a method to a type. So for general purpose data types, prefer a function rather than writing a constraint that requires a method. Another case where type parameters can be useful is when different types need to implement some common method and the implementation for the different types all looks the same. For example, consider the standard library's sort.interface from the sort package. It requires that a type implement three methods: len, swap, and less. This example shows slicefun, a generic type that implements sort.interface for any slice type. For any slice type, the len and swap methods are exactly the same. The less method requires a comparison, which is the fun part of the name slicefun. As with the earlier tree example, we will pass in a function when we create a slicefun. This code shows how slicefun is used to sort any slice using a comparison function. Here, we use type parameters to implement the sort.interface methods for any slice type. Using type parameters is appropriate for this example because the methods look exactly the same for all slice types. I should mention now that Go 118 will most likely include a generic function to sort a slice using a comparison function, and that generic function will most likely not use sort.interface. But the general point is still true, even if this specific example will most likely not be useful in the future. It's reasonable to use type parameters when you need to implement methods that look the same for all the relevant types. Now let's talk about the other side of the question, when not to use generics. When are type parameters not a good idea? Well, Go has interface types. Interface types permit a kind of generic programming already. For example, the widely used io.reader interface provides a general mechanism for reading data from any value that contains information, such as a file, or that produces information, such as a random number generator. If all you need to do with a value of some type is call a method on that value, use an interface type rather than a type parameter. io.reader is easy to read, it's efficient, and it's effective. There's no need to use a type parameter to read data from a value by calling the read method. For example, do not write code like this. This same function could be written without the type parameter. Omitting the type parameter will make the function easier to write, easier to read, and the execution time will likely be the same. It's worth stressing that last point. People familiar with C++ in particular may assume that a function instantiated with a specific type argument will tend to be slightly faster than similar code that uses virtual methods. I said virtual methods because that's what C++ uses. What C++ calls virtual methods is, for purposes of this talk, similar to what Go calls interface methods. In Go, while of course the exact details are going to depend on the compiler, a function instantiated with a type argument will most likely not be faster than similar code that uses interface methods. So don't use type parameters for reasons of efficiency. Use them because they make your code clearer, and avoid them when they make your code more complicated. Going back to the choice between type parameters and interface types, when there's a common method that is used by different types, consider the implementation of that method. Earlier, we said that if the implementation of the method is the same for all types, use a type parameter. Inversely, if the implementation is different for each type, then use different methods. Don't use a type parameter. For example, the implementation of read from a file is nothing like the implementation of read from a random number generator. That means that we write two different read methods, and neither method should use a type parameter. Although I've only mentioned it a couple of times today, Go also has reflection. Reflection does permit a kind of generic programming in that it permits you to write code that works with any type. If some operation has to support even types that don't have methods, so interface types don't help, and if the operation is different for each type, use reflection. An example of this is the encoding JSON package. We don't want to require every type that we encode to support a Marshall JSON method, so we can't use interface types. But encoding an integer type is nothing like encoding a struct type, so we shouldn't use type parameters. Instead, the package uses reflection. The code is too complicated to show here, but take a look at the package source code if you're interested. In closing, this whole discussion can be reduced to one simple guideline. If you find yourself writing the exact same code multiple times, where the only difference between the copies is that the code uses different types, consider whether you can use a type parameter. Another way to say this is you should avoid using type parameters until you notice that you're about to write the exact same code multiple times. Thanks for listening, and I hope you will all use generics in Go when they're available, wisely and well. Thank you.
Thanks, Ian. That was awesome. I know the entire Go community is excited about generics and the implications they'll bring to everyday development. It's been many years in the making, and having guidelines we can rely on will be super crucial in the months to come. And next, we'll be hearing from Steve Francia, who'll be talking about modern enterprise applications. Take it away, Steve.
Welcome to my session, Enterprise-Ready Modern Applications with Go. I'm Steve Francia. For the past decade and a half, I've led industry-changing organizations focused on bringing simplicity to the chaos. As Senior Vice President at MongoDB, I led the development of the first non-relational database to enter mainstream use in 45 years. As Chief Operator at Docker, I led the effort to simplify containers. As a side project, I created Hugo, the most secure and highest performance web engine. Today, I'm the product lead on the Go team, where we are building a modern, simple, cloud-native programming language. Today, I'm here to share with you how Go is helping enterprises modernize their legacy applications. The rise of digital chaos. For years, one of the most talked about topics surrounding the enterprise has been digital transformation. It seems like everyone is feeling the need to modernize their legacy applications. As technology has specialized, it has grown exponentially in complexity. 2 decades ago, there may have been a dozen choices that needed to be made, with typically 2 or 3 options. Today, the amount of choices is simply staggering. Nobody can possibly begin to understand all that is required. 3/4 of CIOs say managing performance is now impossible due to the IT complexity. Security risks have seen a similar exponential expansion. It seems like every day we hear about another major breach. The historical approach to enterprise architecture doesn't work in the digital age. If we don't dramatically change our approach, and soon, it'll be too late. Today, I'm here to share with you what the path is. We need to modernize our enterprise applications, and a lot of folks have this wrong. They have part of the picture, but haven't grasped that true modernization requires simplifying our approach, not simply containerizing it. Since you may not be familiar with Go, I'll first provide a short overview of what Go is. I'll then share with you what a modern enterprise application requires. And lastly, I'll share with you how Go will help you with the migration to modern enterprise applications. Along the way, I'll share quotes from enterprises and how Go helped them. Go is a modern programming language designed by Google for Google's problems of building and serving server-side software at scale. Google uses Go extensively for a wide range of things, from our indexing platform that powers Google Search to the infrastructure Google Cloud is built on. Launched a decade ago, Go has seen explosive growth. Today, Go is a top 10 language with broad adoption among the world's leading enterprises. Go follows Einstein's maxim: be as simple as possible, but no simpler. As Go is designed for maximum simplicity, it is very easy to learn and work with. Go drives the balance between productivity and performance, sharing the friendliness of dynamic languages like Python and the performance of compiled languages like C and Java. As a modern language, Go was designed from the very beginning with security and safety in mind. Over the past 10 years, Go has developed a large and mature ecosystem. Go is loved by both developers and employers alike, ranked as the #1 language across many industry surveys. Go is widely loved by developers because it makes building modern software simple and secure. But what does it take to build modern enterprise applications? First of all, they must minimize risk. They must be fully modern. Adding modern components onto or alongside legacy systems introduces significantly higher risk and complexity. Instead of simplifying things, they triple the complexity. You now need to worry about multiple systems, languages, and integration points. Next, they must be safe. Modern applications have to be built in a way that ensures safety. According to researchers at Microsoft, 70% of the security bugs the company fixes each year relate to memory safety. Google found a similar 70% of serious bugs in Chrome are memory management and safety bugs. Legacy programming languages were not designed with safety in mind because at the time there was no such thing as a cyber attack, and bits were at a premium. Our environment today is vastly different from the one legacy languages were designed for. Modern languages massively de-risk applications. They must be secure. One of the largest risks systems face is in the form of lacking security, which results in leaks and attack vectors. In the constant battle for security, applications need to utilize the latest encryptions and protocols. They need to run in minimal environments with maximum isolation and minimal external dependencies. They need to not depend on legacy libraries and environments. Modern enterprise applications must adapt to business needs. One way they do this is by utilizing service-oriented APIs, approaching applications with a communication-first focus, which ensures that the application has the proper separation, scalability, and flexibility to adapt to new business requirements. This approach also isolates each feature for greater flexibility and security. They must be architected to be modular and composable. Tech debt can be a technologist's worst enemy. This hidden tax slows down all development. Traditional inheritance-based architecture creates code that is very tightly coupled, hard to maintain, and hard to adapt to new requirements. This brings us to our next point. They must be easily maintainable. Teams and priorities are constantly changing. We need code that is easy to understand and pick up by a constant influx of new engineers. We want applications that require minimal maintenance without constant runtime upgrades. Our final theme, modern enterprise applications must sustain growth. They must be scalable and efficient. Data and usage has been expanding exponentially for the past 5 decades. With the end of Moore's Law and increased pressure on computing costs, modern enterprise applications need rapid deployment and the ability to scale up and down with ease, using resources efficiently to keep operating and management costs down. They must have a cloud-native architecture. Modern enterprise applications must take advantage of innovations in cloud computing with a cloud-native architecture. They must be designed with automation, monitoring, and repair from the beginning, favoring managed services. They must incorporate event-driven components, also known as serverless. Event-driven features must be properly utilized to bring cost savings, adaptability, and efficiency to modern enterprise applications. This requires software that loads instantly with minimal resource consumption and minimal dependencies. We're now going to go through these requirements and highlight the ways that Go will help you build modern enterprise applications. Go helps you minimize risk. Go is a truly modern language, requiring a completely clean implementation, keeping your application decoupled from legacy libraries. While there is risk in a rewrite, it pales in comparison to the larger risk of sticking with legacy systems, or worse, maintaining both a legacy and a modern system. Go's high learnability, productivity, and simplicity minimize the rewrite risk and often pay dividends in massively reducing both operating costs and technical debt, further minimizing business risks. Ziviad, a senior principal engineer at Dropbox, said, "People become very productive in Go very fast. Our infrastructure is built in Go today, and all the new things we build in Go." Legacy software languages were designed for a different era where safety wasn't prioritized, or worse, often compromised for performance. This trade-off made sense in a pre-networked era, but has created massive risk in today's environments. Modern languages like Go are designed for today's environments where safety is critical. Go is memory safe, type safe, and utilizes low latency garbage collection. These features alone avoid over 70% of critical bugs, which result from using unsafe legacy languages. Bala, a senior director of engineering at PayPal, wrote, "In our tightly managed environments where we run Go code, we have seen a CPU reduction of around 10% versus C++, with cleaner and more maintainable code." Go has been designed to create the most secure applications, minimizing risk as much as possible. Go applications compile down to a single binary without any local dependencies. It's not uncommon to see an application built using only the standard library or only a couple well-vetted dependencies. Go's dependency management uses an industry-leading tamper-evident transparency log with built-in tooling that ensures your dependencies are exactly what you expect. Go has native encryption, which has been used to power much of the internet, including key components of Google and Cloudflare. Adopting Go means that the next heartbleed, which impacted virtually every application written in any other language, won't impact your application. Go even supports distroless containers, where there are zero local dependencies to worry about. Go helps you adapt to business needs. Service-oriented APIs provide enhanced agility, scalability, and reliability, allowing your business to adapt to market and strategy changes quickly. Go is the only language explicitly designed to build service-oriented APIs. Go has native support in the standard library for all you need to build performant and secure APIs, including a high-performance web server. This is Go's most common use case, with over 70% of Go developers using Go for building APIs. Matt, a principal software engineer at Monzo, shared, Go is the perfect language for creating microservice architectures. The concurrency features and the language in general has allowed the easy creation of small and simple network services at Monzo. A unique feature of Go is that its application structure directly mirrors the architecture of service-oriented systems. Services are designed independently in a share-nothing architecture communicating across networks. Go applications are composed of share-nothing modules, which communicate across channels, a native feature in Go. This means that both your service and your application, which is composed of many services, are using the same architectural pattern. The benefits of agility, independence, and easy maintenance are twice as impactful for Go-based services, which maximizes your ability to adapt to business needs. There's an additional cognitive benefit for developers of using a single architectural pattern at every level of their system. John Graham Cumming, the CTO at Cloudflare, shared about Go, "I came for the easy concurrency. I stayed for the easy composition." And Kubernetes creator Joe Beda tweeted, "Kubernetes success is in part due to Go and the Go community. Go hits the sweet spot for distributed systems software." High maintenance costs ensure that your technology can't properly adapt or support business needs. Go is unique among all languages as it has been designed to minimize maintenance costs. Rapidly evolving teams are common at Google and virtually all enterprises. Go's simplicity, easy readability, and single binary deployment ensures that Go applications have minimal maintenance and that it's relatively easy for someone new to a codebase to safely maintain it. Martin, a software engineer at Trivago, spoke about this hidden benefit of Go. Go's simplicity and its sophisticated tooling let us scale not only our service, but more importantly, the process of software engineering itself. Reducing the friction of onboarding and training someone has a significant impact on the company's productivity, even more so in a constantly moving environment like Trivago. Benjamin Kane, VP and Principal Engineer at American Express, also speaking at Google Open Source Live, shared, "After working on Go, most of our developers don't want to go back to other languages. Go will help you sustain business growth." Historically, CTOs have needed to make an impossible trade-off. Either choose to delay launch as the team builds a scalable application first, or choose to ship a slow prototype early, acknowledging that development will be delayed significantly later, as adoption growth demands a rewrite, effectively having to choose when to be unable to support business growth. Go has eliminated this dilemma. Go is designed for Google scale, with built-in concurrency that takes full advantage of today's multi-core machines and cloud services. Go enables programmers to quickly develop applications that perform at scale. No rewrite needed. Eric, a software engineering manager at Mercado Libre, wrote, "With Go, the company obviated 88% of their servers and cut CPU on the remaining ones in half, producing a tremendous cost savings." Cloud computing brings countless benefits for flexibility and efficiency, critical to sustaining business growth. Go is the only modern language that has first-class support on all cloud platforms. Go is designed for cloud-native applications. Over 3/4 of the projects in the Cloud Native Computing Foundation are written in Go. Go is designed for container deployment with a very small footprint compared to the ship-the-world legacy languages like Java, Python, and Node. Mariano, a software engineer at Moveo, blogged, "Our Go microservices currently build in 5 seconds or less. They test in 1 or 2 seconds, which includes integration tests, and they can deploy new containers via Kubernetes in 10 seconds or less. The key factor here being small images." Among all cloud benefits, serverless has the largest potential for sustaining business growth, with its low cost, instant scalability, and expanded flexibility. Go is an ideal fit for serverless, with broad support on all serverless platforms. Go has very low resource use and nearly instant startup times, especially when compared to applications written in legacy languages which utilize interpreters. Go is well supported on all serverless platforms, and Google's Cloud Run is the ideal platform for Go applications, thanks to its seamless deployment. Go, simplifying the chaos. The biggest impediment to a company's future success is its past success, according to Dan Schulman, CEO of PayPal. Today's business environment is defined by modern enterprises with a move fast and break things culture. Enterprises will need to embrace the process of constant transformation to remain relevant. Go provides the flexibility and performance to assist organizations with application modernization efforts. To learn more about Go, its primary use case, and to read case studies of enterprises who have transformed their organizations, visit go.dev. Thank you.
Thanks, Steve. As a user researcher, I'm always impressed by how much Go users love Go, and it's awesome to see how their developer experience contributes to improving modern application development in enterprise. And next, we're going to hear from Susie Mueller, who will be walking us through how to build better projects with the Go editor. Take it away.
Hey, I'm Susie Mueller, and I'm a software engineer on the Go Tools team, and today I'm going to show you some tips for getting the most out of the editor. The Go community has written a lot of tools to help you build better projects, and these are available straight from your editor. Today I'm going to show you some tips for getting the most out of the VS Code Go extension. This extension is maintained by the Go team at Google and is open source. The extension is powered by a couple of tools, the Go language server, also known as Go Please, and the Go debugger, which is Delve. What's really great about these tools is that they implement the language server protocol and the debug adapter protocol respectively. And this means that these can be used from any editor that implements the LSP or DAP spec. And so all the features that I'm showing today, you could also access in Vim or Emacs or whatever your editor of choice is. And with that, let's hop straight into the demo. All right, I have VS Code open and the Go extension installed. And what we want to do is I have this file containing some text that I want to reverse. So what we're going to do is we're going to write a function that'll allow us to reverse the contents of this file, and then we're going to write some tests for that function and debug any errors that we encounter. And all while we're doing that, I'm going to be showcasing some different features that are available in the editor to make writing Go code easier. So the first thing I'm going to do is initialize my module by running go mod init. So I'm going to do this using a command provided by the extension. All I have to do is specify the name of my module. And a module is just a collection of packages that can be versioned together. And by running that command, it's created my go.mod file for me. So right now it just contains the name of my module and the version of Go that I am developing with. This is the file that will contain my dependencies. And I'm going to run go mod tidy. And this is going to add the dependencies that I already have in my project. So something in my project already depends on X tools, and I can actually check what it is by hovering over this require statement, and I can see that the doc package depends on the loader package from golang.org X tools. So some other code lenses have now appeared, and this allows me to keep my dependencies up to date so I can get the latest security fixes or features from the packages that I'm using. By clicking check for upgrades, I can do this individually per upgrade per module that I depend on. Now that we have our go.mod file all set up, we're ready to start writing some Go code. So I want to write this function near this other function that I know I already have in this workspace. So we've previously written some code that allows us to reverse the contents of a string. So I want to find where that is in my project, but I can't exactly remember where. So I'm going to use symbol search to search for the function. So if this first result is in our string util package, and by opening it, it takes me right to that function. So I'm going to go ahead and start writing some Go code. So I'm going to start by writing out the function signature, and I'm going to accept the auto completions as they come up. And I'm going to fill in the return values. I want to return a string and an error. And that's it. So the first thing I want to do is read in a file. So I'm going to store the contents in this contents variable in the error. And I want to use this read file function from the OS package. I'm going to hit enter, and I'm getting signature help, which allows me to reference what the arguments are as I'm filling out my function. And since this function is from a different package, I have to include that in the import statement at the top of my file. Accepting the auto completion automatically added that import for me, so I don't have to manually go ahead and do it. Now that I have this read file in my code, I can hover over it, see the documentation. I can click on this link to the package.go.dev website, which is a great place if you're looking for packages to include in your project. So if you didn't know that OS had this function, this would be a place to go to find which packages can improve your project. All right, and another thing that we see here before I continue is we have these red underlines under contents error in this last brace. And so these are compiler errors. So if I hover over them, I can see what they are. So I have the contents are declared but not used. So I have two variables that are unused, and I haven't added my return statement yet. And so these are both things that I'm planning on fixing. I just haven't finished this function, writing this function yet, so it's not going to build. So I'm just going to ignore those. The first thing I want to do after reading in that contents is to handle the error. So I'm actually going to do this by triggering a completion and then selecting this first completion item. So this is a common Go idiom where you check if the error is non-nil and then you return the error in default values for the rest. And with 2 keystrokes, I was able to handle the error. Now that I've done that really quickly, I will go ahead and reverse the content. So I'm going to return reverse, and so I've accepted that completion again, and I'm going to pass in contents. And I actually had tried to pass in contents, which was a byte slice, but reverse accepts a string. So the completion actually did the typecast for me, so I was passing in the right type. All right, so I finished writing that function, but I'm still getting this red line here. And when I hover over it, I see that I have the wrong number of return values. So this was the issue, is I want to return both a string and an error, but reverse only returns a string. So when I'm clicked on the line with this underline, I see this light bulb pop up, and in this description of the error, I also see this quick fix. So if I select the quick fix or the light bulb, what shows up is this code action. So this is to fill in the return values. So if I select it, it will attempt to fill in the return values with variables that are in scope and default values. All right, so now we're done writing this function. So I want to write some tests. So what I'm going to do to make this easier on myself is I'm going to use a function, a command provided by the extension to generate unit tests for this function. So I've done that, and now it's already generated all of this code for me. And this may be a lot to read right now, and you don't have to read it all, but the basics are that this code is a table-driven test. So we have these test cases defined by this struct type here, where we pass in the function arguments and then what we expect the results to be. And then the remainder of the code just runs the function that we're testing, and then checks that the results are what we're expected. So I'm going to delete this to-do and add in a test case of my own. So my first test case, I'm about to start typing, but I see that I have this light bulb in the corner, so this means that there's a code action available, even though I don't have an error. So I'm going to trigger this from my keyboard, and I can see that the code action that's available is to fill the struct. So when I select that, it's going to fill in all the fields for me, so now I just have to fill in the values. So I'm going to go ahead and name the test case. I'll use the same code action to fill in args. Give the path to our hello.txt file. I'm going to put what we expect the result to be here, and that we don't expect there to be an error. Okay, so now we have our test case. Let's run this test. So above every test function, we have two code lenses to run the test and debug the test. And by selecting one, this will run the test and show us the output. So I'm going to expand this output view. I can see pretty quickly that this test failed. Something went wrong. Not only did I get the incorrect value, this test panicked. So there was some kind of error that caused our program to panic. So I'm going to use the debugger to look into how that happened. Since I know that the program panicked, I'm not going to bother with setting any breakpoints. I'm just going to click debug test and let the debugger catch the program before it crashes so I can inspect the state at that point. All right, when I debugged the test, it opened this debug view on the left, which contains the variables that are in scope, as well as any variables that we want to watch, and a call stack, which has all of the Go routines that are running, including the one that is currently stopped, is labeled with the reason that it's stopped. So in this case, the panic. So I can look through and see all the stack frames. Additionally, when the program is paused on panic, we also get this exception info in the source code. So this is, you can readily see what happened, like what the error was that caused the program to panic, and as well as inspect the stack frame. So now I'm going to go back to the stack frame so we can pick the last frame that's in our code. So we have a couple of stack frames that are in the testing package, but I want to look at the ones that are in my module. So I'm going to go back here to the one that was in reverse and figure out what's going on. So it's this line 34. Now let's see what the variables were at this time. So our error said that we had an index of 12 that was out of range. And J is 12, so that looks pretty suspicious to me. And R is length 12, so if we tried to index into R with J, that would be an error. So now if I look at the code, I can see on the line before that J was initialized to the length of R. And so if we try to access that right after that, it's going to get an error. So there's just an off by one error here that I'm going to go ahead and quickly fix. So now that we've done that, I'm going to run the test again and inspect the output. So again, we're getting a test failure, but in this case, it didn't crash. This is a different issue than what we had before. So we're going to go ahead and debug this by setting some breakpoints and stepping through the program. So I'm going to start by setting some breakpoints. First, I want to set one here just at the start of this test. And I'll even make this a conditional breakpoint by editing the breakpoint and setting a condition for which it should stop. So in this case, I want it to only stop if the test case name is hello. And if I had many test cases, this could be really useful to get directly to the one that I want to debug. And then I also want to set a breakpoint in reverse. So I'm going to open this debug view actually and select this plus on the breakpoints section to add a function breakpoint. So now I can just type in the name of my function and it will set a breakpoint there. I could have also navigated to the source, but this is a way to easily do it without actually having to find the location of the function you want to break on. So now that I've done that, I'm going to go ahead and click Debug Test. So we're now stopped on our first breakpoint, which is here in our test function. So if we look at the variables, we can see that we are indeed on the test case that we wanted to be stepping through. The name is hello. This is the value we wanted out. We have the correct path to our file. Everything looks good. So now we're going to start stepping through the program. I can do this using the toolbar up here at the top. And so first I'm going to step into this function. So I'm going to step into reverse file. And I'm just going to keep clicking. And actually at this point, I'm in this read file function in the OS package. I don't really expect there to be bugs here. I feel like the problem is probably in my code, so I want to get back out to my code. So I'm going to step out and then just step to the next line. And I'm going to hit continue so that it will continue until it hits my next breakpoint, which is here in reverse. So now it's time to start actually looking at the values and see what went wrong. So I'm going to open up this debug view again and have the variables open. We have the argument, which is the hello world string. And then we have this variable r. If I expand it, I can see each of the individual values as well as a string representation of this slice. So in this case, we can see what all the values are, and we're just going to keep an eye on the string representation. So I'm going to start stepping through the program and see if we can figure out what's going wrong. And pretty quickly, I'm seeing that the end of the string is being copied to the beginning, but the beginning's not being copied to the end. Line 34 was supposed to be swapping these, and clearly it's not doing that. So this is a bug. We can fix this right here by just making this change. One thing we notice here is that what popped up is this yellow underline. And what this is, it's not something that's going to break your program. Your program is still going to build. It's detected that there's likely a bug. So in this case, that RJ is being assigned to itself, which we have this RJ is being assigned. This RJ is being assigned to this RJ. So when we complete this line so that we have the correct swap, that warning goes away. And we've, I believe, fixed our function. So I'm going to run the last test that we tested using a command, and it passed. Great. Now that I've made sure our test passed, I want to make sure that the tests I wrote were actually good. Did they actually cover what I wanted them to? So I'm going to toggle test coverage in this package. And what that is going to do is it's going to, first of all, run this command and print the output. So it's going to test all the tests in this package, run all the tests in this package, and then say whether they passed or not, and also the percentage of statements that were covered. So this is every line that was hit at least once. I kind of want to look more in detail about what is actually covered. So if I go back to my source code, I can see that the lines that are in green were lines that were covered by a test, and lines that are in red were not. So in this case, I might want to add a test that covers this case where the error is non-nil. Now that I finished writing this function and testing it, I could go back and refactor code that I've already written using other features available through the extension. To see a complete list of features, you can check out our VS Code Go documentations to see all the extension has to offer for language features, testing, and debugging.
Thanks, Susie. That was a really helpful demo. It's awesome to see how using our editor extension can make writing Go code easier and more consistent. Next up, Benjamin Kane will talk about American Express's journey with Go, moving from proof of concept to production. Over to you.
Hello, everyone. My name is Ben, and I'm from American Express. And I'm here to share a little bit of our journey with Go and how we went from a proof of concept to writing some of our most critical applications in Go and running them in production. So before I get into the journey, let me introduce myself. So my name is Ben Kane, and I am a distinguished engineer at American Express. My current area of focus is the American Express payment network. Now, I've been working in technologies for a very long time now. Last 10 years of them have been American Express, and I'm actually celebrating my 10-year anniversary here at MX pretty soon. Now, in the time that I've been at American Express, I've been focused on very high throughput distributed systems, working on both the infrastructure and software engineering sides, kind of different roles at different times, but kind of both sides of that fence. And important for this conversation and this talk is I've been working with Go professionally for the past 5+ years. So that's a little bit about me. So why don't we start talking about American Express's journey with Go? It all started roughly late 2016, where a group of engineers who were working on our payments and rewards platforms, we saw that the programming language landscape started to change, and we were looking to rewrite some very core pieces of our platform, some very critical pieces. And we wanted to see what these newer languages had to offer. And some of them promised, working well in this low latency area that we're really aiming for. High volumes, low latency, infrastructure, networking type components. And we wanted to see what would work best. So what we did is we created a proof of concept, a programming language showdown, where we'd write the same service in multiple different languages. And we would test each of those services from a performance perspective and other characteristics to see which language was the best for what we're looking for. And what we were looking for was something that we could write services and platforms that can handle very high volumes of traffic at a very low latency per request. High volumes, low latency. And we're looking for something that was also very easy to develop with. Something that provided modern tooling. Traditionally in the language space that you would use for low latency, modern tooling isn't always there, right? The languages are there, but they don't always have the best developer experience. But we were looking for something that blended best of both worlds. Spoiler alert, we chose Go. Choosing Go, though, wasn't just it was the fastest, so let's go with Go. Actually, it was not that case. Go wasn't the fastest language that we tested. It was pretty quick, and it was definitely fast enough, but it wasn't the fastest. What we found is there were other characteristics about Go that we really liked. For example, while Go may not have been the fastest, it was very easy to write languages that handle lots of services that handle lots of concurrency. We wanted to make sure that we can create these services very easily without having to manage lots of thread pools and manage a lifecycle of a thread. With Go, you can do that with Go routines and how Go handles concurrency. It's very easy to work with. Now, another thing we also liked is the fact that Go is a compiled application. It's pre-compiled. You just start it up and it's ready to go. Whereas some of the other languages we looked at were just-in-time compiled. And when you start those applications up, the virtual machine compiles the code into bytecode. And when it does that, there's a performance penalty. It's called warm-up time. And with Go, there is no warm-up time. It's ready to go. With those languages, that performance penalty can really slow down that service. So while that service may be able to hit a high number eventually, when it's starting, it's sometimes half of that. And that was really key for us because this platform is high volume all the time, 24/7. So we need a service that can start up and be able to handle high volumes immediately. Now, from a performance perspective, we liked Go. It was easy to work with. It was easy to write high performance applications. And that's what we really liked about Go, is just how easy it was. It was easy for us to learn, and it was easy for us to quickly become effective in writing stable applications in Go. And a lot of that is due to the built-in testing and benchmarking frameworks. It's very easy to write high-quality Go code and high-testable Go code, and that led us to writing more effective Go code. And it really didn't take us long to go from learning about Go to writing a very fast service in Go. Now, if you want to learn more about this little proof of concept we did, we published this as a case study on the go.dev website. You can go check it out, look for American Express. It goes in detail about what decisions we made, what we liked about Go, what we didn't like about Go, and all of it's there as of 2016's proof of concept. Now, fast forward, years later, we're running Go in production. We were able to write those key services in Go. We were able to meet our low latency requirements and be able to handle our large volumes that we were looking at. And we've even had some situations where in production, we've had unexpected bursts of traffic, and we've been able to scale to meet those needs. And it's been great. From a performance perspective, Go's not let us down. Now, we've also found that our engineers are actually spending less time writing Go code than some of the other code that's out there. A lot of our Go builds are averaging about a tenth of the time spent building versus other services that are comparable. And this piece, I think, is very important, especially for us, where we're high transaction volume. We need to be very quick and very performant. We've actually spent less time tuning our Go applications versus some of our other applications. And a big piece of that is, if you look at our space, one of the things that we were really worried about was garbage collection time and stop the world pauses. And what we see with Go is our stop the world time is actually extremely low. We don't really have to worry about that too much. We actually, with Go, are spending our time tuning other things, like how we're doing things, writing more efficient Go code, and how many Go routines we have, and managing that, and making sure we have just the right amount. But overall, we've spent less time tuning our Go code than some of our other code. That's actually been really beneficial for us. We've been able to focus more on building more efficient applications from the start. Now, another benefit that we didn't expect going into this, but we're not going to complain about, is we're actually seeing a lot of our Go services use less CPU and memory when compared to another service that's very similar. We're able to actually meet and sometimes even exceed the performance of those other services with less CPU and less memory. And overall, that's led to less of a infrastructure capacity required to run some of our Go services. It's overall infrastructure savings. And that's something I'm also hearing from other industries and other enterprises out there, is that as they've used Go, they've actually decreased some of their infrastructure costs. It's very key when you have lots of applications. For an enterprise, that's a very kind of a great bonus. Now, speaking of being an enterprise, as an enterprise, you obviously are going to have a lot of things out there, a lot of tooling that exists today. one of the areas that we were kind of worried about at first was our observability tools. When we start these Go services and when we run them in production, are we going to be able to monitor them? Are we going to be able to pull metrics and tracing and logging from our Go services like we do with other services? And we've actually been pretty successful with that. It is a lot less work than we expected, integrating Go with a lot of our enterprise observability tools. It's been great. We've been able to do it, and we haven't had any real issues with it. That's not to say there haven't been challenges along the way. The biggest challenge with Go has actually not been anything to do with the language, but more the decision to use the language. So like I said, the proof of concept started with a group of core engineers who looked at the languages and felt Go was the right decision. And of course, those engineers had to convince their leaders and senior leaders, and we had to make the case for Go in the enterprise. But it wasn't an easy case. When you're a big enterprise like American Express, you have lots of different teams. You have lots of tooling in place today, lots of CI/CD tooling, monitoring, deployment tools, and they work with a set of languages and they work how they work. And when you make a choice to allow one team to use a new language, you have to basically also concede that those enterprise offerings are going to support that language. How many teams are going to end up writing in this language in the long run? Is it going to be isolated, or are you going to open the door for everyone? And that was some of the conversations we had to have. At the end of the day, we made the bet on Go. As an enterprise, we said we're going to allow this, and we're going to see how this goes with a couple of platforms at first, and then open the door more wide. And of course, as we went down that journey, some of our internal tooling wasn't ready. We had to go off-roading a little bit, especially around CI/CD and some of our dependency management. And that was very true early on, before Go mod became more, popular and mainstream. We had a lot of challenges of working with dependency management within our corporate network, but we worked through all that. Now that's pretty much not a problem at this point. Now, another kind of challenge along the way was, while Go is easy to learn, when you have a lot of teams working with Go, it takes time to train those engineers. You can't expect an engineer just to pick up Go over the weekend. You want to give them time. You want to train them, and you want to create the resources and create the facility for them to take that time and take that training and all of the information you can give them for learning Go and apply it and learn how to write good idiomatic Go. And some of that comes with experience. And as we were getting and gaining our experience, we created some bugs and we fixed them. And actually, an interesting side note is concurrency is very easy in Go, sometimes a little too easy. And one of the things that we ran into early days in us using Go is actually creating bugs around Go routine cleanup and coordinating between Go routines. And that concurrency was so easy that we actually created some problems for ourselves. And we actually ended up becoming better engineers for it. We learned about those issues, we worked through them, and we fixed those issues. And at the end of the day, our Go code is better and we write better Go. We still have some challenges along the way, especially as we scale Go development across the company. So we have, team over here writing Go code. We have a team over here writing Go code. How do we make sure that the code they write looks the same? How do we establish best practices and create standards that all the teams are going to follow and all the teams like, right? Because of course you can define best practices, but if a team doesn't like those best practices, it's going to be hard to get them to follow it. So how do you create these things? How do you define them? How do you make sure Go is consistent from this team to that team and across the enterprise? And another thing that we're kind of seeing as a challenge is kind of team level hesitation to adopt Go. So you have a team and they may already have a platform, and that platform may already be written in another language. Taking on Go as a new service, maybe it's the right choice. Maybe there's a lot of things about Go that they really enjoy and they like. But taking that and running it in production, now you have two languages you need to worry about. How do you manage that? And how do you make that easier? How does teams deal with having a platform that supports two languages? And of course, with that is, how do you scale teaching Go to all these teams? How do you get all these teams writing good idiomatic Go? How do you get them to write it the same way all the time? And how do you scale that training? So what has not been a challenge is actually getting our engineers excited about Go. We've actually been able to create a great internal community of Go practitioners. Our internal Go channel has over 600 engineers. And what we've actually seen is a couple of core Go engineers create a internal Go user group with many engineers kind of participating. They've created monthly meetups where engineers from across the company will come and share their experiences with Go. Some will share their side projects, some will share their things they're working on, some of the things they've learned. And it's a great kind of internal community just brewing. And this group has also created a yearly Gopher Conference with external speakers, and we'll bring people in and talk about Go and their experiences with Go at their company and what they've done. And we've been able to have two of these so far, with the third one planned for this year. And they've been great. We've gotten great turnout. People love these conferences. And what's come of those is actually groups have been formed that have been starting to create a how to Go documentation. A lot of those best practices and standards, the internal community is starting to create and starting to define. And we feel like that's the best way to actually create these, is getting folks from all around the enterprise kind of contributing and defining that. That way, they'll use it because they're the ones creating it. And of course, with that also goes creating an internal set of packages and a library of packages that teams can use to build Go services and build those services easier. We have things that are for resiliency. We have things that work with internal tools and services. And how do you kind of make that easier to work with? And this internal community is growing and building these things. And that actually kind of leads me into Go used in other parts of the company. We've seen kind of the payments and rewards platforms, and we've talked about that in our case study and kind of throughout the slide, but Go is also used in lots of other places within the company. In fact, our InfoSec team has really embraced Go. They have lots of tools and scanners and things like that written in Go. And one of those is actually a open source project called Earlybird. And they use that to scan code repos for application secrets. If anyone wants to check that out, it's out there available on GitHub. We've also seen a lot of our infrastructure teams looking at Go, like our API gateway team has been looking at Go and WebAssembly and how they can use WebAssembly to kind of enhance our API gateways. And then our internal service mesh team has an internal discovery service written in Go. And a big one that I think is worth kind of calling out is a lot of our internal platform teams have decided to use Go for their platform services. And I think this is key because Go is not just a great language to write a platform service. It's actually a great language to create command line tools with. And a lot of these platform teams, they want to have a service and command line tools that they can give to developers and let those developers interact with their services. And by having one language that can do both is really powerful for them. They can save a lot of energy by just having kind of one focus. And we're seeing that kind of drive a lot of those platform services teams to using Go because it's great for both. And then, of course, we're also seeing Go get used for a lot of our REST and gRPC-based services, a lot of our application backends. And we're seeing Go kind of grow in our application backend space. And we're seeing more and more Go every day. And that's where we're using Go in other parts of the company. If any of this sounds interesting to you, American Express is hiring. Check out our open positions at americanexpress.com/techcareers. And if you want to connect with me on LinkedIn or my website, you can see how to get a hold of me there. Thank you, everyone.
Thanks, Ben, for sharing your insights from using Go at American Express. And that's a wrap. So you know what that means. It's time to join us at the after party by clicking the Watch Live button on the event's agenda page to be directed to Google Meet.
And today's speakers will be also joining, and we'll have some quizzes, interactive activities, and surprise guests. We hope to see you all there. Thank you.